Okay, welcome back. We're on page 65 talking about communications interception. So let's talk about IP spoofing. How difficult would it be, for example, for you to alter the way your IP address appears on the other end of a conversation? Well, it's done all the time with a virtual private network software. So if I'm using VPN, I can make my IP address appear anywhere on the planet that I want. DNS cache poisoning. There's a way that I can instruct your machine to, when you type in, www.microsoft.com, it actually goes someplace else. Yeah. A man in the middle attack. Now, this is not quite as complicated as it used to be. The idea is that that I'm sending something and I'm thinking I'm talking directly from this guy to this guy, but I'm not. I'm actually going through another person. So that goes up to here, then it goes down to here. So a guy in the middle, a man in the middle attack. So quite frankly, this is not something that's all that relevant now. It used to be back in the days before like web services were all HTTPS. And so this would be pretty bad. But now the session keys, there's enough robustness in the transfer of the keys that this is practically eliminated. Okay, so technical hardware failures, page 66. So yeah, hardware can fail. In the old days, you had the Pentium floating point processor bug. But quite frankly, that's not really all that much of relevance today. That's ancient history. But we do have Spectre and Meltdown. And these are because most modern CPUs use hyper-threading, which means one CPU core gets basically broken into two. And so stuff can happen over here and stuff can happen over here. And they're supposed to be isolated. But there's a way you can trick the machine into having this process can see what's going on over here. And there's another one, basically it's called speculative execution. And it's a little bit more complicated, and I'm not going to go into too much details. But basically, yes, there are hardware problems, some of which can be effectively patched by a firmware update on the CPU. Okay, it's called microcode. Okay, so that's a pretty good way of solving the problem. Others just can't be fixed. Well, it's not true. Just turn off hyperthreading. Poof, problem gone. So let's talk about other types of hardware failures that has really nothing to do with viruses or anything like that. Let's say, for example, you wanted to know how long a hard drive is going to last. So there's this company called Backblaze, and basically they just rent out like rack space. Okay, so but since they have an awful lot of hard drives in storage, they started collecting data, and it's absolutely amazing some of the stuff you find. Talks about all this good stuff. And so one of the things I thought was weird is they go through and they'll actually tell you, like, oh man, I have to sign up to be able to get that. Well, I ain't going to do that. All right. So they'll tell you what brand, what model, and what the mean time between failure rate or what the failure rate is, those kinds of things. It's fascinating data. And it basically is, cut through all the lies of the manufacturer and say, here's how long this thing is really going to run. The thing I thought was fascinating is I just assumed that if you had two disks, one that wasn't being used much and the one that was just getting the heck beat out of it nonstop. I mean, it ran nonstop with thousands and thousands of reads and writes. And this one over here just kind of every once in a while. Okay. I assumed that the one with the higher usage would fail sooner. There is no correlation between the usage and failure rate. Wow. Now, we are talking about, honest to God, real spinners. We're not talking about SSD drives. We're talking about mechanical drives here. Okay, continuing. Technical software failures, page 67. So, of course, there's bugs, right? Bugs exist. And there's a bug track software that you can go out and find. You can either report bugs or find bugs. If something is acting kind of strange, then maybe you need to go there and see if someone else is having the same problem. That's what I would do. There's an open web application security. this is kind of cool. Let me just go here and just type in OWASP. Okay. And this, kind of cool because they produce the top 10 web-related security violations. We're going to be going into that in a little bit more detail. It's basically for developers, okay? It's not for the average user. But if you're a web developer, you probably need to be well familiar with this because they talk about the top 10. The deadly sins of software security. So one of them is called SQL injection. And what happens is, we're going to do a demo of this later. What happens is if you have a form that you're filling out, like name, password, that kind of stuff, and you have it so that the text that shows up in the web page gets immediately injected into the SQL, then that means instead of typing my name, I could actually type in a valid SQL command. Okay, so there's this goofy little cartoon that I dearly love. So here's how it is. Gets a phone call saying, "Oh my God, did you really name your son Robert, single quote, parentheses, semicolon, drop table students?" You go, "Yeah, we call him Little Bobby Tables." So what happened is they were expecting to type in a person's name, but what they did is they typed a person's name and injected a SQL command that says drop table students. Wow. Okay. A thing called server redirection. I think I'm talking to this server, but I'm not. It's called cross-site forgery. Again, that's a little bit more difficult to do now that everyone's using HTTPS. Web client vulnerabilities, cause it's basically the same concept, except it happens not at the web server, but on your machine. So this is cross-site scripting. I'm pull down a JavaScript that launches some other JavaScript on somebody else's web page, not the one that I'm currently visiting, but somebody else's. Okay. By the way, web browsers would pick this up in a heartbeat and go, whoa, 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 stop. This ain't right. Hidden URLs. In the early days, this sounds dumb, but when you type out a URL, there is honest to God place where you can put a name and a password in the URL. HTTP, :/ whatever / password equals and et cetera, on the URL. Clearly no one does that these days, but that's how it used to do. Buffer overruns. This is kind of a complicated topic, and I'm not going to go into too much detail. Basically, what it means is if I have a field that's 25, I'm expecting 25 characters, so that's how much memory I've allocated. But I put 50 characters in it, it could overwrite some of my code. And if I do it skillfully enough, I can basically take over. String format, embedding formatting characters like a bold and that kind of stuff when it wasn't expecting it. Integer overflow. What happens, integers maybe go up to like 2 million. What happens if you go over that? It wraps around. Yeah, what happens when you go past the largest integer? In C++, they have these things called a function pointer, and those are very easy to screw up. Catching exceptions. How does your app catch an exception without crashing? That kind of stuff. Command injection, same thing, except instead of being SQL, you're typing in a valid Unix command or something like that. Failure to handle errors. If there's an error, if you don't handle them, they're going to crash. Information leakage. I'm just going to go through these. Race conditions, like two things are happening at the same time, but one of them has to wait for the other. Poor usability. Maybe you just have a form that's just too complicated for the average person to use. No way to easy update. If you make it hard for people to update, they won't do it. Elevated privileges. Does your application really require you to be an administrator, or you just did that for convenience sake? Yeah. Protect stored data. For example, do I have encryption on the stuff that's private? Mobile code. Does someone else download something? Weak passwords. That's kind of an obvious one. Weak random numbers. If I'm relying on a random number to do something. Bad encryption, like I picked the wrong one. Network traffic. You just don't assume that everything's going to be hunky dory. There's never going to be any drops or errors. improper use of the SSL certificate. For example, if a certificate has expired, or perhaps it's on a certificate revocation list, if your application doesn't bother with that, well then, okay. DNS spoofing, and then if you don't use change control is something we're going to talk about in a great deal in an upcoming chapter. Okay, technical obsolescence, page 72. Let me just tell you a story. I remember a friend of mine who had their last will and testament, and they had it in an 8-inch floppy, because that's the system he had at the time. And so he made his last will and testament on a floppy disk. Yeah, there are companies out there that still have old stuff, and you can go to them and you can say, look, I need this converted over to something more normal. So sometimes companies just flat don't retire. I mentioned that, the ATM machines and maybe even the little kiosk are running like an embedded version of Windows, and it could be all the way back to Windows XP, and they just don't care. Like, all right. Theft on page 73. So we could be talking about physical theft. Somebody stole my laptop. Okay. Or it could be electronic. Remember the definition about removal of possession or denied access, right? So my car disappeared, so it's stolen, or somebody burned it, so it's destroyed. That's theft. But copying something doesn't really fit the mold. Now, we have laws that say you can't do that, but I'm just saying it's more of a discussion about, intellectual property than anything else. Okay, so theft has an awful lot of overlaps in other things like software attacks and espionage and trespass and information extortion and compromising. So theft could be practically anything. Okay, we've reached the end of this chapter, and I'll see you guys again in the next chapter.